among animals today, we have this huge array of diversity of animals, right? They live on land, they live in the ocean, they swim, they move. Most of that diversity is actually from animals that have bilateral symmetry, just like ourselves, okay? And that's more complex animals versus things like corals or sponges, which are more simple. If we think about the origins of animals, what our site does is it brings back those bilateral animals which enable all these really extensive lifestyles back into a much older period, into the Ediacaran period versus the Cambrian. Most of what we knew about bilaterians before came from the traces that they made in the sediments, so the burrows or the little trackways. We didn't actually have the fossils themselves. So we knew these things were around, but we didn't really know what was making them. Now we know what's making them because we have those fossils for the first time. So I think it's a really significant discovery that tells us how this immense array of animal diversity emerged.
Yeah, so the traditional view is that in the Cambrian you see this sudden appearance of all these kinds of animals, typically bilaterian animals like trilobites and fish and all kinds of things we see today. But new discoveries like this one are showing us that the story is much more complex and that animals like this may well have existed for some time before in the Ediacaran period.